Okay, we can all be honest. That last video was stupid long. I'm sorry. There was a lot of stuff to cover, and I made it last a little bit longer than I like. Hopefully you were able to make it through all the way. But if not, feel free to email me with specific questions about whatever you did not understand. And I will attempt to clarify. Okay, let me clear. I've got something on my screen. Why do I have something on my screen? I don't know. But you don't care. Okay, 3 objectives today. Solve equations involving rational expressions. We're going to solve rational equations for a specific variable. And then we're going to solve proportions, which really are just an easier version of rational equations. So that last one will not be a big deal at all. Okay, let's get going right off the bat. Let's look at a really basic example. X over 2 plus 8/3 equals 1/6. Now, when I say equations involving rational expressions, this is what I'm talking about. There's 3 fractions here. Those are rational expressions. There's a nice, convenient little way we can make this a whole lot simpler of a problem. If we figure out what the least common denominator is of all fractions in the problem, and we multiply every fraction by that least common denominator, we'll get rid of all the fractions. So let's see it in practice. What are our denominators? Well, I've got let me highlight them here. I've got a 2, a 3, and a 6. Okay, those are my 3 denominators. So among those 3 numbers, what's the least common multiple? What's the first number they'll all go into? I really need to have this thing up on my toolbar. That's okay. They'll all go into 6. Hopefully you see that, right? 6 goes into itself. 3 times 2 is 6, and 2 times 3 is 6. So they will all go into 6. What I'm saying is the least common denominator is 6. Now, instead of rewriting all of these fractions with a denominator of 6, what we're going to do is we're going to come in, and let me get a different color so that this stands out maybe a little bit. And we're going to multiply by 6 on the top of each fraction. I'm going to multiply everything by 6. Now remember, I can do this. This is fine. I haven't changed any values because I did the same thing to both sides of the equation. Here's my equal sign. I did the same thing on both sides of that equal sign. I multiplied by 6 on the left. I multiplied by 6 on the right. So I'm okay. Well, what's my new equation now? Well, I'm going to get even crazier. I'm going to use a different color to show what we can do here. Well, 6 over 2, well, apparently I erased my 2. I did not mean to erase my 2. There I go with my funky pen magic again. 2 goes into itself 1 time, and 2 goes into 6 3 times. And then on this next fraction, I've got 6 over 3. Well, 3 will go into itself once. It will go into 6 twice. And then over here on the right side, 6 and 6 are going to completely cancel each other out. So what's my new equation? Well, let's come over here, and we'll see that my new equation is 3x, right? Because over here, right here, all I have left on the bottom of the fraction is a 1. So I've gotten rid of my fraction. Plus, now same thing on the second fraction. The denominator is a 1, so I've just got 8 times 2 on top. That's 16. And that equals 1. Well, I attempted to erase again. That equals 1. Right? Because the 6 is canceled out. All that's left over here is this 1. Now I know there's a lot of crazy writing going on in that equation, but follow with me from here. Now that we've gotten rid of the fractions, this is a really basic equation to solve for you. Hopefully you've done this many, many times, right? Subtract 16. So now we have 3x equals 1 minus 16 is negative 15. We're going to divide by 3, and we get x equals negative 5. That's the process. I got rid of the fractions by multiplying everything through by the LCD. Oh, that's a messy looking problem I got up there with all those colors now. Okay, I'm not crazy about the red. I do, however, like green. Okay. T minus 4 over 2 minus T minus 3, this one didn't have a tail, over 9 equals 5/18. Kind of the same thing as before, but now I've got a T minus something on the top of each equation. Let me separate this here. Alright, well, look for the common denominator again. I've got a 2, a 9, and an 18. The common denominator is 18. So let me come in here with a different color. Let me multiply by 18 everywhere. If I multiply by 18. And just to help me not get this lost in here, I'm going to put that T minus 3 in parentheses. And I'm going to do the same with the T minus 4, and I'm going to multiply by 18. I'll write it out front. Okay, well, let's look at what happens. If I multiply everything by 18, the right side's easy. That's a 1, that's a 1. Cancels each other out. That's nice and convenient. On the left side, over here I have 18 over 2. Well, 2 goes into itself once, and 2 goes into 18 9 times. Right? Okay, well then I have a 9 under the 18. Well, 9 goes into itself once, and it goes into 18 twice. Let me give myself a little bit more room here. Okay, now let's look at what we have. Let me rewrite this without actually distributing yet. Let's just see what we have here. We've got 1s on all of the fractions, right? You should see that here. Let me highlight. I've got, well, I thought I had highlighted. Let me get rid of that line. We've got a 1 here, a 1 here, a 1 here. So all of the denominators are 1. That's good. That means I can go back to just paying attention to the numerator. Okay, so I've got, I said I was going to use green, and then I'm not. Okay, so now I have 9 times T minus 4. What happened to my minus sign? I eliminated some extra things here, didn't I? Let's put that back in there. There was supposed to be a minus sign and part of a T, and it just magically disappeared. Don't you love that? Minus, now let me bring this 2 I have up here. I'm going to write it in front of the T minus 3 just to make things a little bit simpler. 2 times T minus 3, and that equals, well, it equals 5, because on the other side the 18s canceled each other out. Alright, from here I need to distribute. I've gotten rid of all the fractions. Let me distribute. 9 times T is 9T, minus 9 times 4 is 36. Negative 2 times T, that's a negative 2T, or a minus 2T. Negative 2 times negative 3 is a positive. I do not understand why this thing does not work with me. 6, which equals 5. Okay, so I just distributed both the 9 and the negative 2. Now let's combine our like terms. Well, I've got a 9T and a negative 2T. That is 7T. I've got a negative 36 and a positive 6. That is a negative 30. And it equals 5. Okay, basic linear equation from here. Add 30 to both sides and I get 7T equals 35. First of all, I've really got to get this pen to work better. Now we're going to divide by 7. And that gives me, I'm going to give this fancy double arrow over here to get to my answer. T is equal to 5. So the key is getting rid of the fractions. Once you get rid of the fractions, it becomes a really basic linear equation to solve linear equation. Just an algebra problem. That's not a linear equation. There's only one variable. I'm making things up now. Sorry about that. Okay. Let's look ahead at something that looks slightly more complicated. Okay, let's take, let me go back to black here. I could get this thing to give me more space, that'd be great. There we go. Sometimes I have to trick it into giving me some more space. Okay, we've got, what do I have? I have 4x over x squared plus x minus 30. Oh, you say, that looks much more complicated. Well, fear not. Fear not. We're going to break it down. Plus 2 over x minus 5 equals 1 over x plus 6. Well, would you look at that? My phone's going to ring. And you get to listen to it. Yep, that's the sound of my ringtone. Don't worry, they can leave a message. Yes, I do not have a fancy phone. In case you couldn't tell by the ringtone, I've got an old school phone and I did not import any fun little ringtones into it. And you know what? It does fine. It calls and texts. And that's what it's meant to do. Alright. So don't hate on me for my sorry phone. It's probably going to make another noise at me here in a second when it tells me that I have a message. But I can fix that. Alright. Back to what we were doing. Okay, before you can figure out what the LCD here is, you're going to need to factor that. X squared plus x minus 30. Well, that's actually pretty simple to factor. Okay, it factors 2 x plus 6 times x minus 5. Hopefully, you're comfortable doing that factorization by now. We did that a while ago, but we haven't stopped using it. This should be a pretty basic trinomial for you to factor. Remember, as a refresher, 6 times negative 5 is negative 30. But 6 minus 5 is a positive 1. And even though I didn't write it there, remember there's an understood 1 in there in front of that x. Okay? So that's where I got that from. So in fact, I could replace this original denominator with just x plus 6, x minus 5. And I think I will, since I have the ability to do that. Let me just get rid of all of this. And let me just slide that up there. So this is my new denominator, x plus 6 times x minus 5. Alright, well now, you see, well I've got an x minus 5 in this fraction, and I've got an x plus 6 in this fraction. Well then my LCD should just be x plus 6 times x minus 5, because I could get that from either of the other two fractions. They each share one of those factors. Okay, so if my LCD is that, it's x plus 6, and I didn't give myself enough room, times x minus 5, sorry about that, then let's multiply everything by that LCD and see what happens. I'm going to have to bring it down here below this to write it again. So let me write it again. 4x over x plus 6 times x minus 5. Well, you can see what's going to happen here. If I multiply by that denominator on top, if I multiply by x plus 6 times x minus 5 up here, what's going to happen is both of those factors are going to cancel out. Plus, I've got 2 over x minus 5, and I'm going to multiply by x plus 6 times x minus 5 on top of this fraction as well. Let me extend that fraction bar there. And this equals 1 over x plus 6, and we're multiplying by x plus 6 times x minus 5. Extend that fraction bar. Well, over here on this middle fraction, x minus 5's cancel out, and on this right fraction, x plus 6's cancel out. And I erase part of the fraction bar magically. I do not know why it keeps doing that. I'm not pressing the eraser button, I swear. Okay, so what do we have left? We have 4x plus 2 times x plus 6 equals 1 times x minus 5 is just x minus 5. Okay, we can solve this. Let's distribute the 2. 4x plus 2x plus 12 equals x minus 5. Okay, well, I've got some x's I can combine on the left, and I need to move this x over from the right. Let's do one step at a time, though. 6x plus 12 equals x minus 5. right? Just combined 4x and 2x to get 6x. Now I'm going to subtract this x from the right to move it over to the left. And remember, this is like a 1x. I'm just subtracting 1x is what I'm doing. 6x minus 1x is 5x plus 12 equals negative 5. Now I need to subtract 12. Subtract 12. Well, darn it to heck. My pen. Darn you, pen! Sometimes you just got to talk to the technology. 5x equals negative 17. Alright, this looks crazy over here. Let me fix that. That's going to drive me nuts. Oh, you got rid of me 1, 2. I got to fix that. Alright, here we go. Okay, so I got 5x equals negative 17, so I'm going to divide by 5. I'm going to divide by 5. And I'm going to get x equals, remember these 5's cancelled out, x equals a fraction. Yeah, it's true. You can have a fraction for an answer. It's alright. You don't need to write it as a mixed number. That's a fine answer. Yes, x equals negative 17/5. That's okay. I know you hate fractions, but they can be answers. It's alright. Okay. I think you probably get the idea there, right? If you can figure out the common denominator, multiply everything by that, and you will be on your way. I do want to show you one other thing real quick, because this kind of blows people's minds a little bit. Just a little bit. And I don't want you to have your mind blown. Unless it's in a good way. Then go for it, please. By all means. Okay. We've got two fractions that have an x minus 4 for the denominator. And we've got this 1 over here that doesn't have a denominator. Well, remember, any 1, you can write anything over itself as 1. So what if I replace this 1 with, let me get rid of it, and I wrote it as x minus 4 over x minus 4. Remember, that's got to be equal to 1 because it's the same thing on top and bottom of the fraction. So now you see this problem, all of them have the same denominator. So really all we would do is we would multiply by x minus 4, and it's going to cancel out all of those denominators. And you're going to end up with 2x equals 8 plus x minus 4. And that one's pretty quick to solve, right? Right, of course it is, because you're going to subtract x. 2x minus x is just x, 1x, right? Equals, well, if this x has gone over here, 8 minus 4 is 4, and I'm done. Now, this one presents an interesting issue. We got x equals 4 as our solution. However, if you go back to the original problem and plug in x equals 4, you come up with a little bit of a problem. You get a 0 on the bottom of a fraction. Back up here. If you would replace that x with a 4, you get 4 minus 4 is 0. Well, so what does that mean? What it means is there's actually not a solution. This 4 is not a valid solution. So even though it looks like it's a solution, it looks like the right answer, it's not. The moral of this story is check your answers. Sometimes they don't work. Especially when you're dealing with fractions, and we'll deal with some stuff later with absolute value where you may end up getting an answer that can't be right. So it's one of those funky little things that doesn't seem like it should be possible, but it is. Okay, I seem to be babbling on for too long again. So let me try to pick up the pace. And let me start with a squiggly line, because who doesn't like squiggly lines? The second objective was that we would solve rational equations for a specific variable. Okay. I want to solve this equation for x. Let me write that here. Solve for x. Okay, it's not solved for x right now. Right now it's solved for 1 over x. We've got 1 over x by itself. We want to get x by itself. Okay, let me switch colors here, because I like switching colors every now and then. Mix it up. Okay. Well, my first step is to get x out of the denominator. So let me multiply by x. Now think about it this way. I'm going to put this side in parentheses. I'm going to multiply the whole thing by x, because I'm doing the same thing to both sides of the equation. So let me come down here below my directions and see what do we have. Well, now we have x over a plus x over b, and I got this by distributing the x to both 1 over a and 1 over b, equals 1. Well, we have x on top of each fraction, but we can't exactly combine them because they don't have the same denominator. Well, let's make them have the same denominator. How can we do that, you say? Well, what's the common denominator going to be? If one denominator is a and the other is b, we don't know anything about a or b, we can always get a denominator of a times b. So I could come in here and I could say, well, I'm going to multiply by b here on top and bottom. I'm going to multiply by a here on top and bottom. Remember, since I'm doing the same thing to the top and bottom of the fraction, I'm really just multiplying by 1. I'm not changing the value. So what do I have now? Well, now I have xb over ab plus xa over ab. I just switched the a and the b around in that second fraction. Commutative property says I can do that. And that equals 1. Well, now I have a common denominator. So now I have, let's combine them into one fraction. xb plus xa, all of that over ab, equals 1. Now see, this is, you got to be kind of clever on a problem like this. Now you probably, most of the ones you'll have won't be this complicated, but I want you to see the most complicated one you could so that you can do the easier ones. Okay, well, I've got x, but I need to get it by itself. So what I can do is I can factor. On the top of this fraction, I could factor. Well, I tell you what, I could factor, but let's do it. We'll do that next. Let me do something first. Let's get rid of this denominator of ab. Well, we can do that by multiplying by ab on both sides of the equation, because ab over ab is going to cancel out, and I'm going to be left with xb plus xa equals 1 times ab is just ab. Okay? Now let's factor the x out. If I factor out the x at this point, I've got b plus a in parentheses. I've still got ab over here. Now I have x times b plus a. Well, then let's divide by b plus a, which is also the same as a plus b, by the way. So if you want to switch this around and make it a plus b, that's really the same deal. So now I've canceled out my b plus a, and I have x equals ab over, I'm going to rewrite it, I'm going to switch the b plus a around just because it makes more sense to write it as a plus b. And there's my answer. I bet you didn't think that was going to be that difficult to get x by itself. But it kind of was. Not difficult, just a lot of steps. Let's go back up there and see, right? So we had to recap. We had to multiply by x to get it out of the denominator. Then we had to get a common denominator on the left side so that we could combine those fractions into 1. Then after we combined them, we multiplied by that common denominator to get it out of there, to get rid of the denominator. Then we factored the x out, and then we divided by b plus a to get x by itself. And ta-da! Okay, come on, admit it. It was kind of cool. It was kind of cool how we just manipulated that around to make it do what we want. All right, let's move on. Let's solve proportions. Let me give you, you've seen these before, so I'm not going to spend very long on this. Most people come into this class knowing how to do this already. 45 over x equals 5 over 7. Now, when you're just multiplying fractions together, you do top times top, bottom times bottom. But we're not just multiplying fractions together here. We have an equal sign in between them. Because of that equal sign, this is where you can cross multiply. Everyone has always heard cross multiply and divide. Well, this is where you do it. When you have two fractions set equal to each other. When I say cross multiply, just to make sure everyone knows clearly what I'm talking about. Let me use a different color to emphasize this. I'm talking about multiplying diagonally and setting what I get equal to each other. Some people call it the butterfly because it kind of looks like a butterfly when you draw that, right? So when I do that, when I cross multiply, I'm going to have 5x equals, 5 times x is 5x, 45 times 7, let's see, that's 35, carry the 3, that's 315 is what that is. So we've got 5x equals 315, divide, hopefully both sides by 5 if your pen works, which is lovely when it does, and x equals, well, let's see, what's that, 63, I think. 5 goes in, yeah, 63. So x equals 63. And we can check this. Let's plug it back in. Let's think about it for a second. Does 45 over 63 equal 5 over 7? Is that a true statement? If x is 63, then this should be a true statement. Well, 9 goes into 45, 9 goes into 63, right? If we divide them both by 9, we get 5 and 7. So yes, 45 over 63 is equal to 5/7. Okay, let me give you a word problem because there's going to be some word problems in there. And what I'm going to do here, it's a little quicker if I type it out than if you have to watch me write it out. So let me get the mouse down here and I will just type it out. Let's see, what do we have? We have the quotient of a number and 6 minus minus 5/3 is the quotient of the number and 2. And I'm going to make that bigger, don't worry. Give me a second here and I will make that much bigger so we can read it. Alright, because I know that sometimes on these get fuzzy if you're playing them a little bit larger. Okay, so here's our problem. The quotient of a number and 6 minus 5/3 is the quotient of a number and and 2. Well, let's try to set this up. Let's just set it up as we read. Okay, the quotient. What does quotient mean? It means division. The quotient of a number and 6. Well, I'm going to use x for my number. Right, so let's see. A number. That's x. Okay. So then down here when we have the number, that's x again. So everywhere you see that, we're using x. All right. Well, then the quotient of a number and 6 means x divided by 6 or x over 6. Okay. So I've got x over 6 minus 5/3, so minus 5 over 3 is, now is, this is a key word. Let me highlight that in a different color. Is the huge word here. So I'm going to put it all green. What does it tell us? It tells us something very important. It tells us equals. That's what it means. You could replace the word is with the word equals and it would mean the same thing. You could say the quotient of a number in 6 minus 5/3 equals the quotient of the number in 2. So wherever you see the is, that's where your equal sign goes. And what is it? It's the quotient, division again, of the number x and 2. Now when you're setting these problems up, when they have quotient, the order matters. This is not, like when it says the quotient of a number in 6, you can't switch these. It cannot be 6 over x. That would be the quotient of 6 and a number. The order absolutely matters. Okay, so now that we've got the problem set up, we know how to work this. This looks like the kind of problems we did at the beginning of these notes. Let's find our common denominator. We've got a 6, we've got a 3, we've got a 2. Our common denominator is going to be a 6. Let me get rid of this x here because it's in the way now. Okay, so I'm going to multiply everything by 6. I'm going to multiply everything by 6. I'm going to multiply everything by 6. Well, here in the first fraction, those 6's are going to cancel out. That's kind of convenient. X minus. In the second fraction, I've got this thing going on here. 6 over 3, well, that'll reduce. 3 goes into itself once, and it goes into 6 twice. So now what do I have? I have 5 times 2 over 1. So that's 10, and it equals 2 and 6 can reduce. 2 goes into itself once, 2 goes into 6 3 times, so that equals 3x. Now I just need to solve. Well, I know y'all don't like negative numbers. Nobody likes negative numbers. But the quickest way to solve this is actually to move this x over to the right side. Usually people want their x's on the left, and that's fine. If you want to do it that way, you'll just have one extra step. You'll have to move the 10 to the right then. By doing it this way, I don't have to move the 10 also. So that cancels out my x. I have negative 10, don't forget that negative is still attached to the 10, equals 3x minus x is 2x. And now I divide by 2, and I get not enough space, so let's move down. I get negative 5 is equal to x. Well, let's check. Is that a true statement? Let's go back to the original problem. The original problem said x over 6, so this would be negative 5 over 6 minus 5/3 is equal to the number over 2. Negative 5 over 2. Well, let's see. Let's get a common denominator so we can actually compare. In order to get a common denominator, let me use my blue. I don't know why this draw menu stayed open. That's why it... Go away, draw menu. Go away! How do I make you go away? I don't know. Apparently I've opened up the draw menu and it's never gonna go away now. I don't know what I did. Oh well. Let's get a common denominator. We're gonna have to multiply by 2 on top and bottom of this fraction, and by 3 on top and bottom of this fraction. So now I have negative 5 over 6 minus 10 over 6 equals negative 15 over 6. And you can see, yes, this is a true statement because negative 5 minus 10 is negative 15. So we have negative 15 over 6 equals negative 15 over 6, and we're done. Okay, I said I was going to try to shorten it, and I don't think I shortened it very much, but there was all that information you had to have. So you can now do the Lesson 9 assignment. Good luck!